Hello, everyone, and welcome to the first ROS Mastering Live show. I'm very excited to present that to you because it's the first time that we are doing this kind of interaction with our friends and all the people that is interested on doing ROS and learning a lot of things. So what is about this ROS Mastering Live show? It's a show that we are going to do in order to answer your questions for real life projects. So for example, imagine that you are building a robot and you want to ROSify it. Then maybe you will have some trouble, some problems. Okay, perfect. That's the place where you can ask us questions. If you are programming a software package based on ROS, and then you have some problems, you don't know which tools to use, which libraries, that's the perfect place to ask the questions. So the questions we are going to answer here has to be submitted previously using a website. So let me share with you the screen so you will see what I mean. Is this screen. Okay, so if you visit this website, that the address is www.deconstructsim.com/ROS-QA. So you can ask us questions here, and you will see here that below that there is a form that you can use for sending us the question. So use this to send us the questions for the next webinar. And in case that your questions are selected and are complicated, we'll contact you, and maybe we'll have to have some hangout session where we'll discuss about your problem, etc., etc. So great. So what else? What else? So for today, let's go straight to the first question that we have today. Today we have a big question, let's say a big question, and then a few smaller ones. So let's go straight to the first one, that is the big question. And that's a question that has been done by Steve Duncan from Turkey, that I know that he is listening to the webinar now because I saw on the list of people attending. So hello, Steve, nice to see you again. And Steve had a problem because he wanted to acquire a 3D point cloud using a laser scan. So let me show you here what he wanted to do and what his problem was. So let's go here. Okay, it's not that one, it's this one. Yeah, so in this case, this is something of the setup that Steve did it. So he did something similar to this. It's no, actually this is his picture. He sent those pictures to me. Then as you can see here, there is a motor here. Then there is the laser that is a Hokuya laser, 4 meters Hokuya laser that is mounted on top of this motor that is rotating. And then he has created some electronics in order to control the motor and also to publish the status of the motor, the position of the motor into a ROS topic. So that's a lot of work that Steve had already done, and that congratulations, because that's not an easy thing to do. But what was the problem? So the problem is that he was receiving those scans of the laser, but the scans didn't make any sense. As you can see here in this capture, we can see that the frame of the laser is a little bit strange because the laser has to be very straight and parallel to the terrain. As you can see here, the laser was rotating in a strange way, what was producing a strange laser pattern. Then when he combined all the lasers taken by this configuration in order to create a point cloud, the result was something like that, that really didn't make sense. So Steve was investigating about that, but he couldn't find the error at that point. So he contacted us and we discussed about the problem. So what I'm going to do now is that I am going to show you a recreation of his problem. So I have created a simulation of a similar environment that represents that problem. And we are going to see where the problem was. Actually, it was a very stupid problem, a very simple problem, but the way to reach that point was not so quick. So it took us some time, a few minutes. I think that less than an hour, but okay. So it took us some time. So now let's go and see how I have reproduced this problem, and let's analyze it. Great. For that, what I have done is I have created, I'm using the ROS Development Studio. That is a tool that we have built at Deconstruct. Is this the ROS Development Studio? You can access this tool at this address, rds.deconstructsim.com. That's it. So don't worry about all the links that I am providing during this webinar, because I will attach them below the video. So you will be able to access later when the webinar is finished. Then what I have done in this ROS Development Studio is to create a simulation and some packages in order to control the simulation and reproduce the same problem that Steve had. And it's this simulation here, this project that I call rotating laser problem. So I'm going to launch it and run. And then now the system is going to boot and show us the simulation and the files. As you can see here, we have a Python notebook where we can attach code and other information related to the problem that we are doing. In this case, I haven't put anything, so it's nothing that is not going to be used now. Now, here, what do we have here? This is the IDE. I'm going to refresh this because for some reason, yes, here are all the packages that I have created related to this problem. Those packages include the simulation gazebo, the rotating laser example that I have created. That's an example for Steve's problem, and with all the URDFs, for example, and also the code for making the robot rotate. In this case, it's in Python using ROS. And also we have here a package for making the conversion between laser scans into a point cloud that combines all the laser scans into a single point cloud. So we are going to see that in a few minutes. So, and what do we have here? Here we have the simulation that starts very in the middle of the simulation, but what we have in the simulation is this gas station here. And let me put it bigger so you can see better. Okay, so we have this environment here in the simulation. Very simple environment just for the example, okay? So, and then I'm going to spawn the simulation of the robot of Steve here. So we are going to see that now. And for that, let me just change this configuration in this way so you will see better. Yeah. Okay, so let's go. Then for this case, I'm going to launch here. I'm going to create a web terminal into the simulation. I'm going to launch the rotating, was called like that, yeah. It was called rotating laser description, yeah. Rotating laser description and start rotating laser launch. Now it's going to spawn this. It's going to spawn here. You can see the robot of Steve. Let's call it a robot because it's a sensor with an actuator, and I know it's very simple, but it's doing it. Okay, so what do we have here? A tripod. It's similar, so to represent the same environment that Steve had, and then the Hokuyo here that is rotating. Okay, great. Then now, what's the next thing? The next thing is that we are going to see how this laser has been represented on RBIS. Okay, so for that, let's open a new terminal and launch the RBIS. . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 。 . 。 。 。 。 . 。 。 .
。 . 。 . 。 . 。 . 。 . 。 .
and launch the RBIS. Great, launch it. And in order to see RBs on a web browser, so we have to come back here and press this button here, Open ROS Graphic Tools. And here we have, it's opening. And here we have, okay, so here it is, the RBs configuration. I have created a specific configuration for this environment. So let me open it. It's on the package that contains the laser description here and here. Great. Okay. Okay, so far so good. We have here the representation of the robot in RBs with the links and the different frames. Good. You can see, yeah, the base link and the laser link. It contains 2 links. Now, what we are going to do is to show the laser, how it is represented, how it's been acquired here. So let me get a little bit closer and then activate the laser scan. Okay, so you can see it's a little bit strange. You see, it's like pointing into the ground, but in theory, the laser is rotating here, so it should be capturing all these buildings here. But instead, it's just putting something on the ground only, and just a little bit there, just a little bit there. So let's do one thing. Let's activate the point cloud converter. This is a program that we have created. This is the laser. It's a package, okay? Laser to point cloud. And if you want to know how to build that, we have created also another video previously that is in our YouTube channel of the Construct, that is called How to Assemble Several Laser Scans into a Single Point Cloud. If you go there, you will know how to build this point cloud converter. So I'm going to launch it. Opening, I need a new shell. And then I'm going to launch it. That is ROS launch, laser to PC, and then star converter. Okay, great. So now this package, what it's doing is connecting to the laser scan and then building a point cloud that we can visualize here. So I'm going to disconnect the laser and connect the point cloud. Maybe you will see that the system goes a little bit more slower. Okay, so here it is. Yeah, that's very strange. It's very strange point cloud, you know, it's not what it should be. And this is not the exact situation that Steve had, okay? Because, I mean, I'm reproducing the situation, but the problem was exactly like that. So his point cloud also made no sense. But prior to the point cloud, he was worried about the point cloud. But prior to the point cloud, the problem was on the data that was coming to the point cloud to laser to point cloud converter, that was not correct. So this data here, the one of the laser scan, that's not correct. So we had to find what is happening there. Oh, okay. So then for that, as you can see here, if we approach, it's like the axis of the robot that is rotating are not correct. So if we move closer here, so the robot is rotating, but it is supposed, if we approach the robot, it is supposed that this part here, let me stop it. This part here should be at the bottom of the robot, because the laser scan is field of view starts from this direction, goes straight into this other direction. Okay, so what it looks like is that the model that we have for that problem, for this robot, is that the axes are upside down. We watch it here. Okay, I cannot come closer because I need to select another one. Okay, well, too much. Okay, I lost it in space. Here it is. Okay, so as you can see, the axes are pointing to the ground, and that's the problem. So where can we find this problem? Well, we can find this problem on the URDF definition, and that's where we headed ourselves. So here on the IDE, we can see that the robot definition is described in this URDF file that we have here. Let me indicate that this is an XML, so we can see it in colors. And what is this URDF robot description contain? So basically it contains two parts. The first part is the one that is useful, describing the links and the connection between the links that is useful for RBIS, for the visualization in RBIS. That is what we are seeing here. And then the second part is the one related to Gazebo. So it's the plugins and the transmissions and some things that we need to make the simulation work. So this is not related to the problem, of course, because Steve was working with the real problem. So the problem has to be here. Then by analyzing his URDF, we saw that it is very basic, and it's correct that to be that basic. So it contains just a base link. That is, the base link is the one that contains the tripod here. Then let me change the configuration so maybe you can see everything at the same time. Yeah. So this is the base link. Then we have the link completely. Then we have the laser link. The laser link is the one that contains the Hokuyo laser and also seems correct. And then we have the joint that is connecting both links, the base link and the laser link. So, and what we observe in Steve's problem is that this part was missing. This part was missing. And then why? Because that was missing, then the calculations of the laser frame were not correct respect to the reality, because the point cloud algorithm, the one that is this one, the one that is converting lasers to point cloud, was expecting to be receiving the lasers from a certain position, but it was not, because it was incorrect. And because of that, with a certain orientation, because of that, then the concatenation, the fusion of all the lasers into a point cloud was incorrect. So the first thing that we did was to add this part here. And in this case, I have already included, because it was required, in my case, for the simulation. But by doing this, we were able to observe something better, but still not good. Why? Because we have a problem with the axis. So you have to understand really what these values are, what the axis values are, and the origin also values are. So you have to understand in order to replicate what is showing the real stuff, the real Hokuyo. Then, in this case, I would like to recommend you, in case that you don't understand very well how URDF works, I would like to recommend you the URDF tutorial that is provided by ROS, where you can see here how to build those structures and how a link connects to another link by means of a joint. This is the problem that we have here, is the base link has a problem. It connects to the laser link through a joint. Okay, the links, those links have been defined here on top. This is the link, laser link, and this is the base link. And they are connected through a joint. And then the transformation between one link and the other has to be specified here. This transformation here means how the laser link is changed from the base link frame. How the laser link frame is changed from the base link frame. And the frames are this axis, the axis of reference. You know, this is the axis of reference of one link. This is the axis of reference of another link, etc., etc. So that was exactly the problem. Then we were looking here and watching into the real stuff several times, because we had to figure out how the things were oriented. And finally, we found that those values were the correct ones, because the robot is rotated. So the Hokuyo laser, it's rotated related to the pitch axis, to the pitch angle. And then, because it's rotated in this way, the joint has to rotate by using the x-axis. And that was the proper configuration. So what we are going to do, as you have seen, I have changed now the sign of this. So it has to be minus 157. And then I'm going to save this. Then I'm going to stop the controller for this, was here in this terminal. So I'm going to stop the controller for our robot. Let me stop it. Request, come on. Yeah, sometimes it stops. It takes some time to stop. Here it is. And now I'm going to delete it. So, and launch it again. Here. So I'm going to launch it again. Now it's going to take the new values. You remember that I have modified here. Okay, this minus error here. And let me launch it. Yeah, here. Then it should appear here. Okay, yeah, okay. So we have a problem because the simulation was paused when I killed the model. And that's a problem of gazebo that happens. So what I'm going to do is just to relaunch the whole simulation. I need to relaunch it. It's very simple. In order to relaunch the simulation, just press this button here, relaunch, and then run. So everything here should be killed in all the terminals. Yes, and here too, okay. And here we wait for the relaunching of the simulation. The simulation is here in this window, relaunching. And here we have the simulation, the new one. Let me put it bigger so you can see. And then we can see here the spawning of the new robot with the new configuration. Let's launch it again. Here it is. Okay. Okay, so now you can see that the robot is not, you know, the part of the back that is below here. Let me see if I can achieve in this computer to see the, yes, the angle. So you can see here this part that is indicating that this is the back of the sensor, of the field of view. So now it has changed here in the simulation. Great. So if it has changed, let's go to the ROS and see where I was. Did I launch it here? Okay, let me organize like this. So let's launch it again and see how it happened here. Okay, so let me open the configuration. Great. now we have the axis that is pointing up, and that's correct. That is correct. Great. And then we are going to select the laser scan to see what happens now. Okay, let's see. Let me get a little bit further. Oh, too much. Okay. Wait. Okay. So far, so good. Okay. So here we see now, we see the figure of all the laterals and the ceiling where the robot it is put. So that makes sense. That makes sense. So this laser is making sense because it's more or less representing a slice of the environment where the robot is in. And that's what we saw with Steve when we solved this problem. That's what we saw. Oh, that's making sense. So now let's go again to the point cloud converter, the one that converts laser to point clouds, and let's launch it. And once we launch it, it's there working. I'm going to stop the laser scan and produce the point cloud too. Okay, so now this starts to look like the environment where the robot is. And you can see here a beautiful 3D representation of the area where the robot is located. Wow, that's nice, isn't it? That's amazing. Yeah, let me show you how it is related to the simulation. It's like this. It's being built at present. So now the representation is representing this area like this. So this is what we are seeing here on the RBase. Let me just move it a little bit. Okay, wait to the other side. So we can see both parts that are built. Or maybe I can remove this also. Great. So that's the screen capture. It's nice. Great. So that's how we solve, finally, the problem of Steve. And then, so now, by what I know from him is that he is now on another project based on those results. So I'm very happy for you, Steve, and keep pushing on ROS. Keep doing a lot of experiments with real hardware. That's great. We are going to concentrate here with simulations, but you can explore with real hardware, and that's amazing, amazing results. Great. So that was the end of the big question. So the simulations that we have been creating here are going to be available for all our clients. So we have our Robot Ignite Academy. The construct is the builder of an academy for learning ROS fast, using these kind of platforms that you have seen in using a web browser. So just let me show you very, very quickly. It's very quick because we have also a specific course for learning how to do URDF for your own robot. So this is the Robot Ignite Academy. And we have here many courses, starting from basics for people who doesn't know ROS, and going through all the topics: navigation, perception, manipulation, autonomous vehicles, OpenAI, etc. And we have here one very interesting for the creation of URDF. That's the one that I have followed in order to solve this problem that I have shown you. So all the information that is required to construct this simulation and other more complicated, it's shown here. How to build your URDF for your own robot, how to include the gazebo simulation parts, how to add controllers, sensors, inertias, and some projects that you can do. And what is interesting about this course is those courses in this platform is that they follow the same structure as I shown you here. So I have pressed start now, so the course is starting, and then you're going to have the same platform, but with a guided tutorial here. So you have all the tutorials here for learning how to do your own URDF. and this contains several lessons. You can select the different lessons. Each lesson contains a simulation, etc., etc. So I really recommend you that you do that in case that you need to learn more. Okay, now let's go for the next question. So this is a list of small questions that I have received through the web page that I showed you before. So I have a question from Derek from Poland, and he says, by launching the ROS project, we usually need to run a lot of launch files. That's right, a lot of launch files, as you have seen in this example. So you have seen that I have to launch many, many files. It takes a lot of time and human memory. So in addition, running processes is running in active console mode. So how to do some master launch files which could run on multiple other launch files? And he has looked into one interesting solution that is called the Robot Upstart. It's a package or a series of packages from ROS that allow you to do this. And he says it's a little bit confusing, a little bit rigid, and could you introduce some solutions or ideas? Okay, so I'm going to show you what we do. We actually are using, in order to launch the system, the boot up of our robots, what we do is to use the Upstart system of Linux. We haven't used the Robot Upstart provided by ROS, but maybe we'll use in the future because we come from some legacy from the Linux Upstart. And I will show you a very simple example. So let me share with you the document that contains this information. And it is here. So this is an example of the conf file that you need to create for an Upstart. So if you use the Upstart system, you need to create a conf file where you will indicate a script that you would like to launch during the boot up of the computer. So when your robot's computer boots up, it will go to this conf file and then check for the information that indicates execute here this script. And inside this script, you can use whatever you want based on Linux command shells. So if you need to put this information into a log file, for example, the result of your launch files, you can put it inside that script. If you need to launch many launch files, you can include them into this tcinit.sh file. So how does it work, this? You need to create this file, and you can call it whatever you want. Maybe my startup.conf. It has to be .conf. Then you have to put this .conf file inside the directory of the computer, etc/init. So you put it there, and then that file here will be executed during boot up by the Linux system. So because this will be executed, and you have indicated here your script will be also executed during boot up. And then on that script, you have full control to do whatever you want. That is the way that we are doing in order to solve our problems with the boot up of the computers of the robot. I hope it helps. Next question is from Shubham from India. And he says, I am an electronics enthusiast, recently got interested in robotics and found ROS is one of the legit tools to get started with ROS. I was thinking whether C++ is better or Python for getting started in ROS. Thanks. Okay, my answer is very straight. Python, definitely. If you want to start, then with ROS, you need to start with Python because C++ is too much complicated. The ROS implementations in C++ is a lot more complicated than Python. And ROS in Python is already complicated. So what I suggest you is that you start learning ROS for Python. You will be able to do everything. Everything you can do with ROS for Python. But then at some point in time, you will need more performance for your robots to access some integrate with some, I don't know, with some tools that require you to work in C++. At that point in time, you can do the jump into C++ version of ROS. But you will be equipped with the knowledge of ROS for Python. So you will be able to understand all the differences between the C++ ROS implementation. Because C++ for ROS version is, let me tell you, is quite complex. So it contains a lot more of concepts, of complex concepts that doesn't exist in ROS for Python. And you will have to learn it. So I propose this, start with Python, and then you go to C++ version, definitely. Great, next question. Shulin from the USA. Where can I have a training to teach ROS and SLAM for undergraduate students? My question again, straight. You have to go to our academy, Robotics Ignite Academy. That's the academy that I've shown you here, and it's so easy for your students because they don't have, they can use any computer, a Mac, a Windows machine, a Linux machine. They only need a web browser. They are set up at the beginning of the day, and they can keep on working at home or at the library in the computers of a friend because everything is web-based. And it contains the lessons together with the development environment, experiment environment. So you can do all the commands of you will be able to do into a ROS setup machine. So that's it. And they will be interacting with many different robots. For example, let me show you here, in case that undergraduate students that they don't know anything about ROS, here is your course, ROS Basics. And if you want them to learn about navigation, ROS Navigation in 5 days. Okay, in 5 days means if you are intensive, but you don't need to do in 5 days. You can do at your own pace. So for example, let me start this one course, is the ROS Basics, and you will see, well, it's the same procedure as in the previous course. You have here the notebook that contains the instructions. It works with different robots along the whole course. And you have here, that is loading now, the simulation of the different robots. So they can build here their programs. They can build their programs. They can execute them here. And they can see the results here on the simulation in real time. So this is so fast for learning ROS because you get the result in an instant. So you know when you are doing well or you are not doing well. So, and we have courses for basics, navigation, etc. Okay, so there it is, the answer. Next question. Next question is from Kashif from India also. And he says he is trying to make an autonomous quadcopter. These are the tasks which I want to do. 1, implement a SLAM. 2, obstacle avoidance. 3, self-stabilizing itself in flight collision. Using Xbox Kinect sensor and Raspberry 3 model for more computations. And I want to accomplish all those tasks with the help of ROS. So the question is, are all those tasks doable with ROS? Yes, definitely. Yeah, you can do that. All these things that you mentioned. There are also packages there that you can do it. I haven't used them, okay, because I haven't worked with quadrators, but I know for sure that they exist. Can you name the topics of ROS which I should learn for this project? Yeah, for example, you need to learn ROS Basics. You need to know how to program ROS. You need to know ROS navigation, laser-based navigation specifically, if I think, for simplicity. Then you can move and use Octomap. Octomap, it will allow you to build a 3D environment of all the obstacles so you can plan against those obstacles and avoid them. And then I would say also, I think that I heard some people talking about using MoveIt for defining the trajectories in 3D. Like if you were an industrial robot, but you apply that to a quadcopter. In any case, what I would recommend you is that you go and search for a company that is called Robotics. It's a Spanish company that they are experts in quadrators, and they work with they build quadrators with Linux embedded inside. So you don't have to build your own Raspberry 3 or else. So everything is already prepared. They are experts. They can help you to move towards this program and maybe find some better solutions. Thank you. So Nguyen from the USA, he says that, how can I take your courses if I live in the USA? Very simple. Visit the website, www.robotigniteacademy.com. That's it. It's accessible from everywhere. In China, still we have some delay because of the firewall that China implements, but you can also even use it there. Next question. Hi, Chim Monkey from Germany. What is the difference between Catkin Make and Catkin tools? Wow, yeah. So I must say that I haven't used myself Catkin tools. So I'm always programming with Catkin Make. I don't know why, because I never had the time or whatever. But what I have, the knowledge that I have of Catkin tools is that they are very convenient. So maybe I should move on this direction at some point in time. So then it's what it says, the specifications and the people who I talk to, they say that is a more friendly interface. So you can build, for example, groups of packages instead of having to build everything or build only a single package. With Catkin tools, you can build a group of packages. You can build those packages even without having to bin into the Catkin workspace. So you can be wherever. And you can build also packages in parallel. So you have many CPUs, you can speed up the building process by using the parallelism. Go for it and let me know what are your results, okay? Thank you, Hichem. Then last question is from IDT from India also. And his question is, well, I'm saying his because I don't know if IDT is a name for a male or a female. So then how can I do an export of my model built in SolidWorks into Gazebo? So it looks like he is doing a model of his robot in SolidWorks and he wants to build it into Gazebo without having to do again the URDF as I shown you there. Okay, so that question is I see this question often. And then let me show you a plugin that exists for SolidWorks. And it's here. It's included into ROS Core, and it's called SolidWorks to URDF Exporter. And you can install this plugin into SolidWorks, and then it will generate the URDF of your robot that you can use straight into Gazebo, most of the cases. Okay, so I haven't tested with all, but some of my colleagues here at the company, they have used it and the results were spectacular. So with quite complex robots, they already, the model that they generated were already working in Gazebo without touching anything. And maybe in some cases you will have to adapt some of the results of the plugin, but in our case, it was working straight. So give it a try and let me know what are your results, okay? Great. And that was the last question of the webinar. And let me have a look if I have some questions from the audience, because I haven't been able to watch into the audience chat. So many screens here, and then I wasn't able. So let me check it. Okay, so I see here, okay, so I'm going from the bottom to the top. And here says, I have built a robot which recognizes small red balls, and then it has to catch them. Which courses do I have to follow? Jonathan from France. Okay, Jonathan, in that case, for that, we have the specific courses for you. Let me just go here. Too many controls here, still first webinar. I hope you will understand. So many trouble here. Okay, so it's here. Still have the simulation of the robot there rotating. Yes, for for that question, we have the following courses that I would recommend you. First, ROS Perception, because in this case, we have that specific example that you mentioned that is about a robot that recognizes small red balls and then catch them. So this is exactly what this course contains, among other things, okay? So it's about Vision Basics using blob tracking and Vision Basics, okay. Yeah, so in this unit, you will see, this is the unit you will see contains the two things, blob detection and then tracking. The first thing you will detect the blobs based on color, and then on the second part, you will learn how to make the control for tracking it. So it means to follow the blob. Then once you know that, you need to know about how to grasp it. And that's the course that you will have to do, ROS manipulation in 5 days. And this is the one that allows you, it integrates vision that you have learned previously in the other course with grasping. And there is here adding perception to manipulation and then doing the grasping. Then it shows you how you can create the trajectories and the grasp movements that you need in order to grasp those objects. This is not an easy thing. So it contains a lot of tricky parts. So, and also there is no documentation where you can look at and see for information about how to do that. So our courses are so good because of that, because we have made this compilation of the documentation that exists from one place to another based on our own experience, and we have put everything there. So I highly recommend you that you do those two tutorials, courses. Now another question. Here it says, Abdal Rahman, he says, VREP or Gazebo as simulator. Thank you for your efforts. Yeah, so in my, VREP or Gazebo. Well, VREP is a very good simulator. It's definitely a very good simulator. But I mean, what can I say? Gazebo is also good, and it's getting better and better and better. And it has a huge team behind that are the creators of ROS and very professionals. So also I'm more in love of Gazebo. The integration with ROS is easier. You can find a lot of people around that can help you with Gazebo. So for me, it will be Gazebo, the answer. Then Muhammad says to send the slide. Okay, I will do it. I will post them here. Not a big thing, but yeah. Okay. I could is saying, did you cancel accepting new ambassadors? I didn't receive any feedback yet. No, we are not. We have not canceled that. We are overloaded. So we are handling the requests as we can, as fast as we can. But as you can see, we have to do a lot of work. Preparing those webinars also requires a lot of work, but also other tasks about creating the courses, going to the conferences, talking about that. And so please just be patient. For those of you who doesn't know about the ROS Ambassadors, it's a program that we have for doing meetups in your location where you live. So you have to do meetups for teaching ROS in exchange for having free access to our academy. You can also do, instead of meetups, you can do videos in your own mother tongue explaining a ROS topic. And then, so by doing this, you get into the ROS Ambassador programs. That is a program created by Deconstruct. And in this program, you get free access to our academy for learning whatever you want. Okay, what else? I see here a discussion between Steve and... Okay, so and Benjamin. So they are discussing. Great, this is great that the people who is attending and they are talking about the problem. Hello, how can I, is a question from the little Ganesha. How can I develop a web interface in PHP and link all the ROS topics and simulator in that interface? Okay, so that's a lot of work. Actually, I wouldn't recommend you to use PHP. I would recommend you to use JavaScript, but that's a lot of work. There has been some work already done, and you can look for robot web tools that are some packages with ROS support that you can use it for starting this work. But you will have to use JavaScript. In our case, we are also using Django. So it's a lot of work. It's a tough thing. So, but go for it. Look for robot web tools. And okay. Okay, so I think that I have covered all the questions that are in the chat. And so that's all for today. And as promised, before we are finishing before the time, 5 minutes before 7, and I'm happy, very happy to have you here. This is going to be the series of a weekly webinar, and we are going to do with more projects, with more tools for ROS programming, and with news, books, etc., etc. So keep coming to this webinar and keep pushing your ROS learning. Cheers, mate.